Hello and welcome to my channel, where in this series I take you through past VCAA Maths Methods exam questions and provide you with full work solutions. In today's video we'll be going through multiple choice questions 17 and 18 from the 2020 VCAA exam 2, so obviously Calc-active. As always, I'll invite you guys to attempt these questions first before I run through the solutions. Without further ado, let's get cracking. So question 17 reads, let f of x equal the negative log base e of x plus 2. A tangent to the graph of f has a vertical axis intercept at 0c. So the y component is that c value. The minimum value of c is. Now for a question that's not too wordy by large, it is maybe quite challenging to get your head around what this question is actually asking for. So whenever I find myself in that position, I like to draw out a visual representation of the information that we know. So the function f of x we know is a negative log that's been translated 2 units to the left. So we know we're going to have a vertical asymptote at x is equal to 2. And it's a negative log. So roughly it looks something like this. And we know it's telling us this tangent will have a intercept at 0, c. So where to from here? So hopefully you guys understand what it means by tangent, and we know a tangent could look anything at this point like that, or if we took a tangent at a larger value of x, we may have something like that as an approximation. So you can see for this first red line I've drawn, it would end up having a y-intercept down here, and the second red line I've drawn ends up having a y-intercept, another y-intercept up here. This question is asking for the maximum value of c, where c is this y-intercept. So we can see if we want to maximize the y-intercept of the tangent, well, what is the largest value that we could come up with? So this is a large negative number. As we increase, it's a smaller negative number, and the maximum would be, if not a positive, the smallest possible negative number. So we can see if we were to take the tangent at the exact point where x is equal to 0, therefore this function would have, the tangent to this function would also have a y-intercept at that same point. And that would be how we would go about maximizing the value c there. Once you get to that stage and draw that conclusion, the maths behind it and doing the calculations aren't too difficult. So what do we need to do? We need to work out the tangent at that point. So actually we don't even need to work out the tangent. All we need to do is work out the value of that intercept, which will be the same value as the y-intercept of the original f of x function. So that all we need to do is take f of 0, so the function f of x when x is equal to 0, sub that in, and this will be both the y-intercept of the function f of x, but also the tangent at that point. So this here is our answer for C. And this looks like it is option C there. Great, so hopefully you guys understand that solution. Moving on to question 18. Let A be an element between the range of 0 to infinity and B be a real number, an element of the real field. Consider the function h, which has a restriction on the domain, and h of x, the function, is a divided by x plus b. So should be familiar with this type of function. It's going to be a hyperbola, and again going to take probably a similar approach to the previous question, in which we'll draw out what this function h of x could potentially look like. So we should understand that it's been translated b units up. So it's been translated b units up. Actually, it may not be translated b units up, as b is just an element of a real field. So it could be negative, so it doesn't really matter. It's just a translation of b units. So it could be above or below the x-axis. It shouldn't actually matter in terms of drawing it, as long as we mark in that y-intercept of b. Great. And this hyperbola doesn't have any translation left or right, so therefore the other asymptote is along this y-axis with an equation x is equal to 0. We know that a spans between 0 and infinity, so in other words, a has to be positive. So if a is positive, then we can draw this with positive shape. So a hyperbola with positive shape would look something like this. Next, we have to consider the restriction on the domain. So we know that the restriction on the domain goes from minus infinity up to 0, sorry, minus a up to 0, and that would be a closed circle. So that will encompass the left-hand side of the function, and then for the right-hand side, we know we're going from 0, so the right-hand side of this asymptote, up to the value a with another closed circle. So I guess I can mark in a, can mark in minus a. So hopefully that's nice and clear so far. And then in terms of finding the range, so if we want to find the range, we will need to work out the exact coordinates of these points, and we do that just by subbing a into h of x. So h of a would be a divided by a, which is 1 plus b. So therefore the coordinates of this point here would be a and 1 plus b. Next, this point over here, subbing in minus a, would have a divided by minus a plus b, or in other words, we'd have minus 1 plus b. Great, so now in terms of working out the range of this function, hopefully this step is relatively straightforward. You should know that the range spans from minus infinity up to this point here, or the y value of this point, which I'm just going to change the order, b minus 1, in union with the other segment of the line here, which is b plus 1 up to infinity. b plus 1 to infinity. Great, so hopefully that's an option here. It looks like that's option D to me. So not too bad, especially when you've got a visual representation to look at. Subbing in these two endpoints, then we can work out the corresponding component of that coordinate, the y value, and then from there the range is relatively straightforward. Looking at the examiner's report, so we'll jump back to question 17. We had 42% of the students answer C correctly, and the notes there look to say the maximum value of C occurs when the tangent to f is at x is equal to 0. So that's what I was trying to illustrate before by drawing a couple of different tangents, and then we could sort of conclude that's the one that would have the maximum value of C would have to be when x is equal to 0. That's really a bit of an abstract problem that you need to solve, and then the math sort of ties in with that. And it's almost impossible to do if you didn't have a visual representation of what this function f of x would look like. Question 18, we had 43% answer correctly, with a large percentage of people incorrectly answer C. So you can see the only difference between C and D was the rounded brackets. That's really caught a lot of people off guard, and I guess people have just been confused. We know that the way the domain is defined, we are including minus a and a, so therefore we would be including it from a range perspective as well. The comments in the examiner's report just go to mention they take again a similar approach. However, they estimate b to be 2 in the plot that they've drawn there. And it doesn't matter, we solved that in terms of a generic solution. Great, so hopefully you guys found this video useful. If you did, then please leave it the thumbs up, share it with friends or classmates. If you're new to the channel, then please subscribe for more content like this in the future. Lastly, if you've got any specific questions you'd like to see me answer on the channel, then please send me an email at yourmathquestions@gmail.com. Thanks for watching, guys. I'll see you in the next one.